Hey all, I hope I am audible and clear without any disturbances. Okay, so I welcome you all for our 14th batch on PostgreSQL and Power BI course. Okay, so I will just give a small introduction about why we have taken PostgreSQL and Power BI course. So if I show you this simple diagram or simple picture which you are seeing on your screen, right? On the left side, we have a data factory. On the right side, we have some dashboard, right? And Power BI is the bridge for this one. So in the current world, whichever the business or organization you are taking, everything is digitized, right? So that means all the activities are captured in electronically. Earlier days, it would be in the books. So small organizations maintaining it is very easy, but when it goes to the bigger organization, then there is a mismanagement happens with the books, right? Now it's slowly technology evolving. I don't say slowly, rapid technology evolution has happened, revolution we can say, right? With the rapid technology revolution, almost all the businesses, all the organization, whether it's government, public, private, everyone has moved to digitization. Even if you go to small shop in a corner of the streets, they are also going to have a small laptop or computer or just a billing machine, right? And all this information is captured. And the market leaders like Google, Microsoft, Apple, and they are providing their cloud services to the small businesses also. So that means major companies, they have their own infrastructure. They are capturing their data into their servers. At the same time, these cloud services, Microsoft, Apple, they are helping these small companies use the IT services and create their own data sets, right? Now, there is a huge demand for the data engineers or data analyst who manages these data or who can manage this infrastructure and create a meaningful insights. Why I am saying meaningful insights is it's very important. Having asset is one thing, but how we are utilizing that asset is very important, right? Having knowledge is important, and at the same time, how we are using that knowledge. Is it helping us growth, whether mentally, financially, or whatever it may be, right? So in the market, there are lot of business intelligence tools are there. Out of them, the top leaders are like Power BI and Tableau, right? And you compare again with Power BI and Tableau, like both are market leaders. At the same time, Power BI is very user friendly and it's a Microsoft product. So the benefit of this is that whoever opens the Power BI, they feel that, okay, we already seen this particular tool. The reason because it looks similar to the Microsoft Office tools like Microsoft Excel, PowerPoint, and all those things. And it's very good for beginners. I'm going to show you that comparison, right? So our target is to achieve or get a business insights to our leadership team or to operations team, how our business is going with the help of the data that we are having. So for that one, the tool we are going to use Power BI. Okay. Now, why Harish has taken a three topics. If you see here, we have data warehousing, PostgreSQL, and Power BI. If you ask me that do we need to really learn these two things before Power BI? No, not a mandatory. Then why Harish has chosen a PostgreSQL and data warehousing, two concepts. Okay. So when I have a discussion with Lakshmi, right, what Lakshmi said that is that, hey Harish, the students which are approaching us is their majority or non-IT background, right? And they have a lot of interest and they want to change their career path, right? Then I thought that, okay, it's not just about we are giving one tool, But if we let them know how this tool is using its previous stage, okay, so from the basics, I just want to make sure, okay, you understand from the basics how the data is originated, how it is arranged and stored, and finally how we are using. Okay. And also, it's very important that a data analyst or a data engineer should be having a sound knowledge on SQL. Okay. SQL means structured query language, right? It's a kind of a like a universal language. If you see, English is there, right? How English is there, where if a person knows English, he can communicate across the countries. Similarly, SQL is a universal language for majority of the databases in the current world. So that is the reason I have added PostgreSQL, right? Along with that, we have a data warehouse concepts. These are the concepts or like a fundamentals. So my thought process is that whichever the field that we choose in, that we should be very strong in fundamentals. If we are strong in fundamentals, obviously we can easily learn subsequent things. Okay, so data warehousing tells us what is the purpose of storing this data and what is the best ways that we should store the data, right? So our course is covering the journey of the data from the collection, which we call as data factory, right? So the data warehousing and PostgreSQL are going to cover this block, data factories block. And finally, we are going to focus on the Power BI, right? So that by when we come to the end of this course, you have a understanding how your data journey is going on, right? Suppose you are working on Power BI, someone asks you, where is your data, how it comes? So you should be very confident and telling, yes, boss, this is my data journey, right? From the collection, organizing it, and finally, how I, as a Power BI developer or Power BI data analyst, using that data, right? So our entire course of 15 days is also divided like that. 10%, one class for data warehousing, 30% for PostgreSQL, and 60% for the Power BI. So we would be learning the first fundamentals. What is the purpose of our course and why we are taking this course? Second thing is we are going to understand SQL language, and I am going to help you on how we can easily write the SQLs. See, SQL structure query languages can be having, sorry, one liner, and it can have 10 or 20 lines also. But the underlying fundamental or concept is simple. If you see in mathematics, you can have a complex formulas, but when we break down it into pieces, it will be having the basic arithmetic operations like addition, subtraction. Similarly, SQL also same thing. Okay. Finally, we would be seeing the Power BI. And Power BI course, we are going to cover around 60% of our entire course journey. We're going to make sure how to get the data into Power BI, how to build visuals, and how to present them in a fashionable way, right? And as I told you that the students that is approaching Lakshmi or our organization are new to IT, so I'm going to touch from the basics, fundamentals, and then we will go to the middle level. Okay, so students who are knowing, I mean, if you know these topics, then I would request you that your support and your contribution also helps a lot to the classes, right? At the same time, students, if you have any small doubt, also you can ask me. Don't think that, okay, is this doubt can be silly or not, because you are not going to decide whether a doubt is silly or not. Smallest doubt, or a funny doubt, whatever you have, please put that one over the chat channel. I'm going to help you to clarify. Okay. This is all about course outlining and how our journey is going to be. And I'm going to record the class and I'm going to upload these recordings in the YouTube, and each and every student is going to have the access for those recordings. Okay. I can simply give you the Zoom link, but I thought of having it in YouTube because all of us are now familiar with YouTube. Whenever we have a free time, I mean, we try to open a YouTube and watch the recordings. So now what I would request you is, from today onwards, next 2 months, you just practice whenever you have a free time. Open your class recording, watch it, take a notes. Whenever you are at home, practice them. Okay. Any questions till now with respect to the course content and what we are going to take up? And in the meeting invitation, you have this attachment, right? So this attachment gives you what are the topics that we are going to cover each and every day. Okay, day wise, topic wise, which are the areas we are going to cover. Okay. Okay. If you don't have any questions, then I will go to the next. In terms of opportunities, okay, we have a immense opportunities with respect to with the Power BI. Okay, we have a one group, dedicated group. Okay, if you see here, Power BI job support. Okay, so this group is dedicated to all our students. I'm going to add the students who are completed the course, and we are going to post regularly what are all the openings available. And I personally guide each and every student for the resume preparation, right? Because resume preparation is a kind of one-on-one activity. It's not a group activity. I'm going to explain you how to prepare a resume, how to keep it. At the same time, once you come up with your draft resume, we are going to sit and review that one. Okay. And then parallelly, I also provide a guidance to the certification course. Okay. There are a lot of openings and market is very wide with the data, because market is having a crunch with the skilled. Why I'm putting this word, please take it, that skilled Power BI data analyst or data analyst. See, UK jobs, US jobs, lot of jobs. If I just open couple of links, I just opened them. See here, we are seating data analyst with Power BI dashboard and visualization tool, right? We are data analyst with 3 to 7 years experience, both data management skills as well as proficient with Power BI creating dashboards. We are going to see these things. We are going to cover proficiency in Python, SQL, DAX, Microsoft Power Queries, mastery in Microsoft Excel, right? So good number of jobs are there. It's just that we are getting the required skill by a consistent practice and becoming a Power BI data analyst. Okay, these are cloud solutions, architecture, data engineer or Power BI developer, Cardiff. This is from UK, I think. Salary wise also there is a good salaries are there based on the experience or expertise that we are going to gain. Okay. But if you see this chart group, daily almost 5 to 10 profiles we are posting and students are picking, and accordingly we connect with one-to-one with the students. Okay. Any questions till now? I would request you to post your queries or questions over the chat channel. Okay, fine. Then let us start the today's class. So our first class is data warehousing concepts, right? Have you heard about data warehousing or a warehouse? How many of you heard the word about warehouse? So I just want to make sure our class is more interactive, okay? Just not one way. So I'm just looking a response from all of you. When you heard the word called warehouse, what you feel?
Is that where the data is stored?
Yes, correct. You can post it in the channel, okay, chat channel. You are absolutely right. Okay. That is a place where data is stored, correct? And data can be stored in different ways. Okay. Like if you see the warehouse of any of the retail company or a manufacturing company, if you see the manufacturing company, they are going to have a warehouse for their raw material. At the same time, they maintain a warehouse for their finished goods, right? And depends upon their requirement, they are going to use those warehouses. Similarly, our data warehouse is a central repository for informations. Okay. So if you take in a general scenario, right? Whenever you go to the bank or a mall or a shopping mart like Walmart, anything, when you go to the billing counter, they will quickly do the billings very faster because we can't wait because already we done lot of shopping. And finally, when we come to the billing counter, our billing should be done very faster with fraction of minutes, right? That means the system should be very fast enough and good enough to do the day-to-day job, right? When we say day-to-day job, it's like billing the things or validating any information and capturing whatever the transactions that we are doing, right? So whenever we say day-to-day transactions, we call them as a operational data. Got it? So operations, day-to-day operations, not medical operations. It's like in if you say the manufacturing units. So day-to-day operations, suppose employee goes to the office and he puts his attendance. That's a day-to-day activity. Similarly, if you got the raw material, then you are going to capture all those information, how much raw material has came into the factory. These are all called day-to-day transaction and this information would be stored, right? Now, if I just show you in a simple diagrammatical way, normally, whenever we say databases, right, the icon that we are going to use is, let me show you that one, shapes. This is the default icon that we use for the database representation. Okay, so this database, that means the place where data is stored in the form of tables. So whenever you want to represent a table, it's like this. Table 1, if I copy this and paste it, so you have another table, table 2, table 3, like that we can have multiple tables. Even if I interpret this one to our house, right? If you see, we all live in a home, right? If you consider a database is like a house, then you can consider each table as a room. And as we know, right, each room has its own purpose. Like kitchen is going to use for cooking, hall is for living, and bedroom is for sleeping. Similarly, in a database, we create different tables. Each table stores one of its kind of data. Suppose if it is a customer table, it's going to store all the customer information. Okay. If it is a sales table, it is going to store all the sales table. Okay. Similarly, if you have a marketing table, it's going to store the marketing data. And if you ask me why we are having this money, to make sure we are storing our data in an organized fashion, so that whenever you want to retrieve the data or information, it would be very easy, quick, and faster, right? So whenever we are storing all our operational data, then we call those systems as OLTP, online transactional processing systems. Okay. Simple word, straightforward. Okay. Nothing to confusion also. Let me merge more cells. Right. So whenever you go to the bank, you do a transaction. So whatever the databases, those are used to collect our day-to-day activities, we call them as online transactional processing systems, right? Because they connected to the online systems. And the important thing is they should be good enough. They should be faster to retrieve smaller information. Why smaller information? As a customer, right? If you go to the bank and ask, hey, this is my customer ID. I want to do so and so activity, that I want to deposit some money. Then they immediately need to set your customer ID. And whenever they search with your customer ID, they are going to get one record and they are going to display on their systems. So online transactional processing system should be having very faster. And if you see the banks, the global banks like Barclays, Bank of America, whatever you take, so they are going to have millions of customers. So from the millions of customers, they need to search one record and give it to you, right? So these are called online transactional processing systems. So you can have multiple online transactional processing systems. Control C, Control V, right? For each and every department, you can have these databases splitted again further with respect to each and every department. So loans department, savings account department, or current account department, right? Now to analyze the data, right? Think of it. So you have a billions of data. Now at the end of the day, you want to know some kind of information or insights, like what are the total new customers joined in the bank today? What are the total deposits made? What are the withdrawals happened, right? To analyze this information, so there should be a process that aggregates the entire data and provide you the results, right? So if we are doing those huge data processing on the online transactional processing systems, there may be chances that our systems may get down, right? Because on one side, it is being serving to the online traffic where a lot of customers are coming and they have queries. At the same time, if you're running very huge queries that scanning entire table, aggregating the data and trying to pull some insights to make sure that this analytical part is not impacting our online activities, data warehousing suggests that take a copy of the data daily at the end of the day and keep it in another database. Okay, and keep it in another database as per your requirement. Not a direct likely copy. You can take a copy, but you can transform the data as per your requirement and then use it for analytics. So this part is going to be a data warehouse or online analytical processing, OLAP systems. Now what happens daily at the end of the day? Okay, since your business is completed, that means, okay, you are closing your shop, right? At the end of the day, a single copy would be sent from these systems, copy of the data. Okay, so next day morning, our analytical systems or we like data analyst, we can start analyzing our data from these systems. And we call this system as online analytical processing. Now, whenever you are doing the analysis, okay, just think in a layman language. Don't think technically. So you have a list, you have a table that is having a student information or employee information where they are having their salaries. If you want to see what are the total salaries paid to the employees, then what we do, we sum up all those things. And at a times we sum up them based on the department. So for each these kind of activities, definitely we need to scan entire table, right? So as and when table grows, you need more processing power. If your data is increasing, say your customer base is increasing, you are opening new branches. That means your customer base increases. That means number of records in our tables is going to increase. Accordingly, we need to improve our systems. Will you agree with me? Will you agree with me, all of you? Thank you. Right. So this is the concept. So we are data engineers or data analysts. Why we are having the lot of job opportunities is that because we need to get a copies of data from the online processing systems, get it arranged it into the nice way, and we need to work on this data warehouse so that we can create a meaningful insights to the Power BI. Okay. So based on the organization size, okay, if you are having a small organization, possibly we need to take the responsibility of taking the data into our analytical systems and creating the dashboards. Okay. Even our Power BI is also having the capability to create data warehouse to some extent. Okay. So if I show you a nice diagram of this one, let me save this one. I'm going to share this file with you. DWH. Okay. Insert picture, online picture, data, spelling wrong. Yeah. The best thing I do is to use the available stuff so that we don't need to worry about creating a lot of new things. Yeah. This gives a nice picture. So if you see here, I have my operational systems on the left side. All right. These are going to be the backend systems for the front-end user interface which we are seeing, right? If you go to the bank and ask the cashier that this is my account, please deposit. Immediately cashier opens your account number, then he will get the information on the screen displayed. That information is not static, okay? It's a dynamic one, right? It is stored in these databases on the backend systems, right? So backend systems are like that. They don't be visible to us, but they are sitting on the back side, but supporting our front end applications, which we are seeing. Okay. So whenever we say front end application, see this Edge or the Chrome browser, these are front end applications because as the end users, we can see them, right? As and when I open this particular link, I get this entire information. This information would be stored in the form of a page or in any data table, right? So that is called backend systems. We call databases. All the databases are termed as a backend systems. Okay. Now coming back to here. So all our system operational data, let me what I will do is I just want to minimize this one so that I can show you. Yeah. Okay. So online systems, online transactional processing systems, right? So we have different databases and we are going to take a staging area, right? So I just put it here, data warehouse. But what happened is that we would be having a staging area. Staging area means just taking a daily copy. Suppose today 100 new records are added and 50 records are updated. So what are the records? Those are having changes. Those copies would be taken to the staging area, right? So staging area is a place where we take the copy of the changed records. So today business is closed. We take a copy of this one and then we load it into the warehouse. So if you see in the warehouse, we have raw data, which maintains the history. So in online systems, we keep the current values or latest values. But in warehouse, we keep the raw data as it is. Suppose if your address is changed over the last 6 months 3 times, then we keep them, all the three of your addresses, so that we can easily know customer has moved from which location to which location. Summary data. So what are the total customers, total deposits, total loans disbursed, and metadata. Metadata is very important in the warehouse. Metadata means information about your data, what kind of tables you have, what kind of information is present in that tables, right? So once we prepare data warehouse or a data warehouse engineer, then small data marts would be created for each department. So data mart is nothing but a data warehouse. Okay. Just it's a subset of data warehouse. Just remember this one. Data mart is a data warehouse only. Just it's a subset of the data warehouse. Suppose if you see here, this data warehouse is built for entire organization. Now within the organization, we would be having like departments, purchasing department, sales department, inventory. We take a subset of that one so that those users can analyze specific domain specific data. And finally, the analysis, reports, data mining. As the end users, either we use Power BI, Tableau, or any kind of business intelligence tool, right? So this is the end-to-end flow of a data journey from data factories to the insights that gives to the customers, right? So I have handpicked articles, okay, that I'm going to share with you. if you see here, is a central repository of information that can be analyzed to make more informed decisions. Data flows into data warehouse from transactional systems, relational databases, and other sources. That's what happened here, right? See, transactional systems, other operational systems, and flat files. Show tab. So data and analytics have become indispensable to business to take competitive. So in today's world, if you want to be competitive, then you should be having data and analytics, both the things, right? Now, how is data warehouse architecture? So is made up of tiers, top tier front-end clients that represents results through reporting, analytics, and data mining tools. The middle tier consists of analytical engine that is used to access and analyze the data. And the bottom tier is database servers where data is loaded, right? So like that. So the top tier where end users like a Power BI report users or any machine learning, all those things. A data warehouse, within the data warehouse, this is the important thing. What are the benefits of using a data warehouse? Informed decision making, consolidated data from many sources. So that's what we have seen, right? Consolidated data from the many sources. Historical data analysis, as I told you, right? We are going to store the raw data and all the historic data would be stored, right? Data quality, consistency, and accuracy we are going to maintain. And for a give a meaningful insights and accurate insights, the first is that your data should quality should be very good. Okay. If there is a compromise with the data quality, then we are going to get wrong results, which means business will take a wrong decisions, right? So whenever we are starting our Power BI reports, we should be doing some basic data analysis also to understand what is our data. Is it looking good shape or do I need to do some cleanup of it? Those can be understand by reviewing the data or by creating a visual. From the visual also we can understand it, right? Separation of analytical process from data from transactional database, which improves performance of both systems. So this is the first point we discussed, right? So we are separating the analytical process with the transactional processing. So if you are having less data and if you have a system that can has the capability to do both the things, yes, you can stay on one systems, but it depends upon our appetite. Okay. Similarly, data warehouse and we have data lakes, right? So hope you have heard the word about data lakes, right? So whenever we are terming databases and data warehouse, they are like a structured, organized data. So if you take this within the database, you define each and every table and you define the each and every column name and what should be the data type that it should hold, right? So if you remember, whenever you are creating a simple table, right? What you do, serial number. Suppose if you want to create a small table, right? So first thing we do, serial number, name, right? Address, and what else can be having? Date of birth, right? When you create this simple table, you know what these columns are going to capture, right? Suppose serial number, I know it should be integer, Name means something, a string value. Address means again it's a string value. Again, date means it should be a date value, right? So accordingly, we define these table. Whenever you are creating a table in database, we tell, hey, my serial number is going to a integer. That means your database will allow only integer values. It don't allow the string values. We are going to see further more in it. Whenever we say date of birth, you mention the data type the data it can accept is date only. Okay. Whereas data lakes are like can store the semi-structured and unstructured data also. See, typically business uses a combination of databases, data lake and warehouse to store, analyze the data. So whenever we are terming as data lake, so it stores structured data like data warehouse. Along with that one, it has the capability of to store the unstructured data also, like images, files, objects, all those things. So those things we call as data lake, right? So let me come back here. We have seen OLTP, OLAP, data warehousing and data marts, right? Now let us see Inmon and Rolf Kimball theories. We all know Newton laws, right? Or many of you know, right? Newton laws. So in physics, whenever we are terming it as a physics, then immediately it comes with Newton laws, right? He has proposed some laws, and till now we are following those laws. Newton first law, second law, third law, or we call it as theories. Similarly, in the data warehouse world, we have two scientists, W.H. Hinman and Rolf Kimball. So they have proposed the theories. Okay, boss, you decided that your company want to build a data warehouse. Now, which approach we need to follow? How we are going to organize our data? Then W.H. Inman and Rolf Kimball, they came and they proposed. And these are the two most common architectures prepared. Okay. So I just got this article in a comparative way. Now, what Kimball approach is design data warehouse introduced by Ralph Kimball. That's why he has kept his name. This approach starts with recognizing the business processing and questions the data warehouse to answer. Now, what Kimball says is that, okay, you decided that you want to build a data warehouse. Now, the architecture you need to follow is, uh, first of all, identify your businesses, right? So what it says is that identify your each and every business areas. Say you are getting data for your sales team. You have a production lines. So from the production, you are going to get lot of data related to the production activities or manufacturing activities. Now create a data mart for each and every department, right? Then join them as a data warehouse. So this is like and if you see in a Scrum, what it says that go in a iterative mode, right? Divide your bigger project or organization into smaller parts and then start building each and every part, or we can say feature. So what Kimball is saying is that boss, you identify your departments, whether it's a marketing department, sales department, or any other department. Now build a data mart, then get all those into the data warehouse. From that, you can create the reporting layer, right? This is what Kimball says. That one, what it says is that setup and build are quick because we are starting with each and every department. Generate report against multiple star schemas. We will see what is this star schema, with a example from the data. Database operations are very effective, occupies less space in database and management is easy. The reason because each and every department has their own data mart, so they will focus on their department specific data marts. So they don't need to bother about organization level department. Whereas Inmon suggested, no, don't go with the department levels, right? You define your data warehouse at your enterprise level. So enterprise level means from the top level. So what Inmon says is that as you have data coming from different source systems, build a enterprise level. That means at the organizational level, a data warehouse. And whoever want a specific department wise data, they can create their own data marts. Nowadays, we are calling these as a business layers, BSLs, business layers, right? So in this case, what the thing is that you need a lot of money and efforts, initial investment, because we need to get all the systems at one place and we need expertise who can interrelate, who can make those relationships in a logically valid form and then create a data warehouse, right? So what is your suggestion? Which one we should take up? If you got a understanding about Enmon and Ralph Kimball's architecture, which architecture will you prefer? Amanda, Nina, Omoloro. Okay, you are saying you want to go, Nina want to go to Kimball. Amanda, Laura, Kenny. Okay. So let us see what are the differences between these two things. Okay. Even though if we all suggesting Kimball, why Inmon is also in learnings? Let's see. Hmm. So if you see the differences between Kimball and Inmon, okay, since they have the person they kept name approach, it has a bottom up approach for implementation. Yes. Kimball, what it does is it will review each and every department and take up it. In Mon, it has a top-down approach for implementation. Hmm. Data integration, it focus on individual business areas. It focus enterprise-wide areas. It is efficient and take less time for building time. It is complex and consumes a lot of time. Yes, it is a complex one because we need to understand. Cost-wise also, it has iterative steps and is cost-effective. Its cost is huge and development low. Skills required, it does not need such skills, but generic team will do the job. So if you take this point that if you are from the marketing department, yes, you know well about your team or your marketing business, how it works. So that it don't need a generic skill will help. Whereas in Mon, it needs a specialized skills to make work because we need to get different departments at one place. Here it is. I think here the Kimball is having here maintenance is difficult, right? So why it has mentioned the maintenance is difficult? The reason because each and every department they creates their own marts, right? Suppose if you see in each and every department, we should be having a table for employees. So that means within the organizations, you are going to have multiple employee tables in different data marts. And there may be chances that since employee switches between departments, Every time the employee name may repeated. Here maintenance is easy. So this is the plus point for Inmon. Since you have the central system, normally we say, na, let us have a control set the centrally. Let's have a central system that can monitors and controls everything. So in that point of view, Inmon is the best one. It maintenance is easy. Data model. It prefers data to be denormalized model. It prefers data to be normalized model. Now, I want to take here a pause to explain you what is denormalized model and what is normalized model. Guys, this is very important topic. Normalization and denormalization. Okay. So our entire data warehousing concepts is correlated with this one, this concept. So we have a transactional or we have a operational systems. When we get a copy from it and store in the warehouse, we try to keep our data normalized. Now, what it mean by normalized? I just want you to be more attentive here, right? To explain this particular topic, I have some handcrafted some data. Let me open that file. Okay. I want all of you to be more attentive. Okay. It's like a climax scene. Whenever you have a movie, when you come to the end, you would be having more interesting, right? Whenever you do the climax. So I hope you can see this table, right? This is a transaction table, right? So which is storing all the transaction information, transaction ID, product name, customer name, and his address, right? So I have taken a sample record of say 7 record. Just think of it. I'm a regular customer to that particular shop or store, and I'm going very frequently, monthly 10 times, right? So whenever I purchase something, then this particular table is storing my entire information. So think of it. In that case, Harish information is going to be repeatedly stored for 1,000 times. Similarly, like me, there are other customers would be there. So if you take a major cities, right, there would be thousands of customers who regularly visit the same stores. So all our information would be stored in detail, right? So what happens if we are storing all our information in a plain text? So which means a lot of disk space is needed, and we all know, right? Space is very costly. If you want to store more data, then you should be having uh, more capacity on your servers. That means you need to purchase TBs of disk space, and these space don't come on free, right? It is costlier. But what we are going to do with the entire those disks, we are just storing the redundant information, repeated information. Now take simple chocolate product name. Now everyone buys chocolates. So every time you are writing chocolate, chocolate, chocolate in the product name, right? So do you think that storing data in a clear form, we normally call it as a clear form, okay, is going to increase the space utilization, that too by storing a redundant values, a repeated values. So whenever you are filling an application form, right, we to give all the information. That means the application form table should be having all the information. It's one of case. But when we are doing a transactions, a single person coming multiple times, is it good to have all his information again and again in the transaction table? So I'm just looking for your opinions, right? Yeah. But if you have the requirement, you can have it. So if we are storing all our data in single table with detailed, right? We call it as a denormalized form. Now, how we are going to handle this situation? I don't want to store the data in repeated way. At least I want to minimize the uh, space utilization for the values that I do repeatedly, right? So for this one, we have a concept called normalization. That means, suppose if you have a customer information, okay? So we are going to create a customer table. See here, customer profile table. And this profile table is going to have a customer information at one time, right? And we will give a reference number to him. Like, right? Whenever you see in an organized, in a school or a university, whenever you first join, they will give a student ID. And that student table is going to have all your information. Further, if you are registering to any of the sports activity, any of the subject, they are not going to use your entire information. They will ask you your student ID. Hey, please provide your student ID. So we share the student ID. Similarly, one time I'm going to store the customer information in the customer table. Similarly, one time I'm going to store the product information in the product table. And I'm going to have a reference of these items so that while using the transactions, I'm going to use these IDs, product ID, customer ID. Now just think of it. Instead of having these repeated words, mobile, laptop, chocolate, I can just have a repetition with their ID. So that means almost I am reducing my space utilization exponentially. So if it takes 20 bytes to store the name, say Michael, now it just takes 1 or 2 bytes to store Michael's ID, which is 2 or 3, right? That means we are reducing our space utilization by 10 times, right? So we also need to make sure, okay, if there is a product ID is there, that this product ID has a referential integrity with the products table. So these relationships we add in the database. That is the reason we call all our database management systems as relational database management systems, RDBMS, right? So what the database, it organizes your data in a more effective way, it by reducing the redundancy in different tables, right? Suppose even if the address can be repeated multiple times, then it use. If you see here, customer address, in the customer address, we know in a particular city you would be having millions of customers. Now, do we need to again write the city name and state name? Suppose here California, state California, that means it needs 40 bytes. Instead of, I will have the IDs, city IDs, and I just store in the numerical value. And another good thing is in the databases, storing data in numerical values is more effective than storing the data in the string values. Okay, so systems would be faster, takes less space, and while you're doing any analytical operations, you will get the good results, right? So in a nutshell, normalization is about redistributing your data, right, in more effective ways so that you can reduce the redundancy. So if I take the topic, let me take the article also for you. This article again I have pulled from the schema, right? Now here it is. Now if you see this sales table, now it is connected with customer table, products table, right? So what we call this sales table is the fact table, which is going to store the transactional information or artifacts about what is the activity happened. A transaction happened, an activity happened, a observation, temperature. And these tables which are storing the information related to the objects or people, persons, we call them as the dimension tables. These tables are storing dimensions. And since this fact table is surrounded by these dimension tables, we call it as a star schema. See like how it looks. A sales table is going to store the unique IDs of each and every product, date, or customer. And whenever you need the full information about those unique IDs, it will refers to the corresponding dimension tables. And since it looks like a star, we call it as a star schema, right? So if you see here, it is usual for a Power BI schema could be comprised with single table. Okay, with the current real-time world, single table is not possible. We should be having multiple tables. A single table can be a simple design, but that's suitable for a data exploration. Optimal model, right? But one that's an optimal design, an optimal model adheres to the star schema design principle. A star schema refers to the design approach that commonly used by relational data warehouse designers. Just think of it in our Power BI also we are discussing about this star schema or data warehousing concepts. That means our Power BI also follows that basic fundamentals, right? Star schema refers to a design approach that commonly used by relational warehouse designers because it presents a user-friendly structure and it supports high-performance analytical queries. The design principle is called star schema because it classifies model tables as either fact or dimensions. In a diagram, a fact table forms the center of the star, while dimension tables, when placed around a fact table, represent the points of the star. Right? So if I show a comparative, dimension table stores business entities, stores events or observations, includes key columns and descriptive columns for filtering and grouping. So a dimension table is going to have key columns and the descriptive columns of the organizations for filtering and fact table includes the key column and numeric measure column that can be summarized. It is going to have a key columns and the numeric values that can be summarized, say product quantity, cost of the product, total cost. We can summarize them. I'm going to share you this data Excel sheet also for your easy understanding and comparative. Data value typically contains fewer rows, right? So if you consider, I mean, if you see comparatively, a customer table would be having fewer rows, whereas fact table is going, suppose transaction table is going to have more rows, right? Because single customer do hundreds of transactions or tens of transactions, can contains numerous rows. And dimension tables uses for filtering and grouping, whereas fact tables to summarize the data. Okay, so this is all about normalization and denormalization and further how it looks like a star schema. Are you clear till now? So we covered star schema, we covered immonent normalization and denormalization. We have seen dimensions and fact tables. Okay. So if you see here, this particular image, one dimension table connected to the multiple, sorry, one fact table connected to the multiple dimension table. So this called as a star schema. Okay. Now there is another schema called snowflakes. Suppose this particular product table or customer table is referring to another dimension table. Suppose if you see here, customer address table is a dimension table for sales table. But again, this customer address is having city ID that refers the information from the city table. So that means second level. Parent, child and grandchild, like that. So the more you denormalize the data redundancy would be reduced, but the number of tables would be increased because you are distributing your data further drill down. Okay, fine. So just to give a recap of what we learned today, we have done our introduction about data warehousing. Okay, what is its purpose, what is its how to arrange it, and we understand about OLTP, online transactional processing systems, and online analytical processing systems. Along with, we have seen Inmon and Ralph Kimball architectures. I think when we are covering this one, we have seen normalization and denormalization at the same time. We have seen the star schema, right? So when I came back further, so data stores, source systems are highly stable. Source systems have high rate of changing, right? Since we have organization level, so your source systems may scale up or scale down, right? We have seen data warehouse and data marts. Data mart is a subset of warehouse. Star and snowflake schemas, data normalization and denormalization. These concepts, data normalization, facts and everything, right? They will be continue in our journey in our data world. Whatever the tool you use, suppose we are learning Power BI. So once we are done with Power BI, we got a job. And after that, if you are moving into Tableau or any other BI or any other cloud systems, these concepts more or less intact and they come in our journey along with us. Okay. So we need to understand them to our heart, not just like, okay, we read it, okay, we remember it. No, we need to be part of them. They're going to be part of our journey, right? Dimensions. So tomorrow's class, we will start with PostgreSQL, right? Since we'll understand how we are going to store our data in databases, now we'll learn more about a database, right? And the SQL from tomorrow's class. Okay, so let me pause the today's class here.